Today, the topics of my discussion is projectile. It is a chapter of A-level physics or similar grades of examination across the globe. We throw a lot of things in our everyday life. The particular type of throwing is included in physics in the chapter entitled Projectile. At first, let me define projectile. An object that is thrown is known as projectile. You can say like that. An object that is projected is projectile. As you think to define it, the path that a projectile follows is trajectory. It is parabolic in shape and it's a geometrical shape. In fact, a shape of an analytical geometry, and it is like this. It is not circle, it is this parabola. Parabola. There are two types of projection that are usually discussed in A-level physics. Type 1, an object is thrown with a constant horizontal velocity from the top of a height, for example, from the top of a cliff. Type 2 is an object is thrown at angle alpha to the horizontal angle, an object is thrown at angle to the horizontal with a constant velocity. Today, I am gonna discuss projection of type 2. For this, consider a stone is thrown at angle alpha to the horizontal with velocity v meter per second. There are 5 patterns of question usually examining body ask you to solve. Typically, question 1, find the maximum height reached by the stone. Here, stone is the projectile. Find its time of flight. It is in fact the time how long the stone is in air. Question 3, find its range, that is maximum horizontal displacement covered by the stone. Find the angle of projection, for that its range is maximum. And question 5, find the angle at which it hits the ground. The stone hits the ground. This question depends on the circumstances that has given in the question. Therefore, I am not going to discuss question 5. I'll discuss it later on. And to solve this question, let me draw a diagram. This is horizontal ground. This is vertical. Axis, and the stone is thrown meter per second meter per second at angle alpha to horizontal, and its trajectory would be like this. Trajectory. Now, first resolve this meter per second into its horizontal component and vertical component. Horizontal component of horizontal velocity is horizontal velocity v cos alpha. Vertical velocity v sin alpha. And at question 1, I have to find maximum height. Think like this way. Here, maximum height, maximum height reached by the stone. This edge, direction of v cos alpha edge, v cos alpha, and direction of v sin alpha, v sin alpha is shown, and maximum height is this. I call it is max. Sorry, is max. And applying the equation of motion, v square equals to u square plus 2as. The stone thinks like this way, as if the stone were thrown vertically upward with velocity v sin alpha meter per second, and it travels from here to here, and direction is this, and then it returns back to its initial position here. Therefore, displacement, therefore, this at maximum height, at the top of maximum height, vertical velocity is 0, therefore write 0, and value of u is here is v sin alpha, therefore v square sin square alpha. 2, a is replaced by minus g and s by is max. Now make is max is the subject of the equation. This gives v square sin square alpha by 2g. Here g is acceleration due to gravity, and its typical value is 9.81 meter per second square, and this is maximum height reached by the stone. Now, question 2, time of flight. In this case, applying the equation of motion, S equals to ut plus half at square. And since the stone travels sorry, battery of my laptop is alerting, and the stone travels from here travels from here and then here, then it's return back to its original position here. Therefore displacement in this case is 0, and u is v sine alpha g square. This implies that p multiplied by v sine alpha minus half gt equals to 0. And solving this equation, one is t equals to 0, another is v sine alpha minus half gt equals to 0. Therefore half gt equals to v sine alpha, and t equals to 2v sine alpha by t. This is the time of flight, or the stone age. During this time, the stone age in air. Of course, this t equals to 0 has a meaning. It represents time when it is thrown. Therefore, time of projection is found. Option 3, the range. Range is maximum horizontal displacement. This is the range. And we use a simple equation of motion is S equals to Vt, where d is constant uniform velocity and t is time. Here he is replaced by v cos alpha and t is to be sin alpha by g. This equals to v square g multiplied by 2 sin alpha cos alpha. There is a formula in trigonometry that sin twice 2 theta twice x equals to 2 sin x cos x. And you can write, you can replace this to sin alpha cos alpha by sin 2 alpha. This is the range of the stone. Range of the stone. Range equals to v sin 2 alpha by g. Sorry, I did a mistake. V square sin alpha, v square sin 2 alpha, v square sin 2 alpha, range is v square sin 2 alpha by g. This is the range. Now, question 4 is angle for which range is maximum. And range is range, right, the range 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 expression of the range is v square sin 2 alpha by g. And we have to find the maximum value of this expression. And v square g is constant here, therefore it is wise find the maximum value of sin 2 alpha. We know that maximum value of sin theta is 1, therefore maximum value of sine 2 alpha equals to 1 and alpha equals to 2 alpha equals to 1 2 alpha equals to 2 alpha equals to 90 degree and alpha equals to 45 degree. That is the required angle if required angle if the stone is projected at 45 degree to horizontal with same velocity, it gives maximum horizontal displacement. Therefore, now I am dealing with a practical problem. The problem stone is thrown at angle 30 degree to the horizontal ground with velocity 10 meter per second. Find maximum height. I repeat the process I used in question 1. The situation can be described as like this. This is 30 degree to horizontal and this velocity is 10 meter per second. Therefore, resolving horizontally gives horizontal, sorry, in this case, you are required to only resolve the vertical component. Vertical velocity is vertical velocity equals to 10 sine 30 degree and 10 into half is 5. This is initial vertical velocity, and applying the equation of motion, v square equals to u square plus 2 as final velocity is 0 at maximum height, and 5 square minus 2g is max, and follows is max equals to 5 square by 2g. From the calculator, it gives the value sorry, I'm calculating. Yes, I found 1.274 meters to 3 decimal place, the maximum height that stone reached. For the second question, range of the stone, range stone. Sorry, it's not range of the stone, it's question 2h. Which time of flight, time of flight, it is how long the stone is in air, and applying the equation of motion, s equals to ut plus half h square at maximum. In this case, displacement is 0 and initial velocity is 5 minus h square, and solve the equation. Five minus half gt equals to 0, t equals to 0, and half gt equals to 5, and t equals to 10 by g. Using calculator, I am calculating 10 divided by 9.81 is 1.01336 second. And here a degree of accuracy is important, and this is typical problem. You can repeat the step 3 for range and maximum range is always uh, when the angle is 45 degree. And now I am pointing out some particular points regarding projectile. Vertical, this is very crucial to know. Point the vertical velocity and horizontal velocity are independent. Independent. That is, one is not affected by the other. Horizontal velocity remains constant. According to Newton's first law, an object is at uniform velocity continues to its state of motion until or unless any resultant force acts on it. Vertical velocity is continuously affected by g. G is acceleration due to gravity. And another point is why the trajectory is parabola. But right trajectory is parabolic in shape, but it is a question that why it is parabola in shape. If we consider like this way, one component, this is horizontal component, this is vertical component. One component remain constant, another velocity is decreasing while moving upward. Therefore, you can point this way. For the second case is the horizontal velocity remains constant and vertical velocity decreases. Therefore, the shape is easily determined by this way. That is how the shape is parabola. And one assumption in projectile is we always assume that is any drag force or air resistance is completely neglected. And in practical problem, as at question 5, this the situations are actually given. In fact, in real life, there are there are drag or air resistance acts in projectile, whatever it is, stone or cricket ball, etc. And today I have to finish my class. In fact, I messages to all who is gonna see my lecture over YouTube. If it is beneficial for you, you can subscribe my channel, and my best wishes to you all.